right, good day and welcome back to Everything Mathematics. And today we're continuing our series on simultaneous equation. And today we're going to just dig a little deeper into identifying or being able to work with this guy's simultaneous equation. When it comes to simultaneous equations, of course, it can be presented to you in many different ways, several ways. But in the topic of CSEC, oftentimes when dealing with simultaneous equations, these are three common ways in which sometimes an equation is presented to us and we don't recognize them because we don't see them as a simultaneous equation. And it will be rather sad to know that you know to solve a simultaneous equation, but in this case, you cannot solve it because you did not recognize it. So yes, as I said, over the years, these are three common ways in which you see it. Sometimes you present it as you would present it with a simultaneous equation, but in an unconventional way. And this simply means oftentimes in textbooks and even when we are taught, when we practice, usually we see x and a y, of course, equal to something. But you need to know that not all the time you'll have an X and a Y. Sometimes you'll have an A, or you have a B, or you have any other letter. But again, as I said, because we don't expect simultaneous equation to come with anything except X and Y, and I would think mostly because of how we taught. Even for me, to be honest, the first time I learned that it could actually be anything else, I was a bit surprised. I always thought it was about X and Y. Yes. The other issue, of course, or the other way which you could come as at these guys is that of rearranging to suit. Not all the times when you get a simultaneous equation, for instance, you'll get it as x plus y equal to, let's say, 3, and then you get x plus 2y equal to, let's say, 4. Not every time you have your x's already line up for you, your y's already line up for you, and your constants already line up for you. Sometimes they are disarranged, let's put it like that. And you have to arrange it to suit. And that's one of the ways in which they come as a disguise. Because oftentimes students may not recognize that, oh, if they had transposed or if they had moved, then they would have an equation suitable to what they are accustomed to or ready to be solved. So that's another thing we need to be very cognizant about. And last but not least, of course, you have word problem. So sometimes you are presented with a simultaneous equation as a word problem, but let's say you're not equipped to recognize that it is a simultaneous equation in the making. So these are three common ways. I'm not saying they are the three common ways, but certainly there are three ways in which you commonly tend to meet a simultaneous equation. So with that said, let's see if we could solve a few simultaneous equations, and I will do it in order. So I'll look at the first example when you have an unconventional letter. And just to know, this does not show off anything that you do. It simply means that you have to be aware so that when you see it, you solve. So here we have an example. Here we have what? 12p. And as usual, I did not solve these questions beforehand, so I have no idea what I'm supposed to get. I hope they work out nice. And then you have 4p plus 6q is equal to 5. And right away, you can see here that I know probably we are accustomed seeing again the x and the y. So some persons may see a p and a q and it's like, no, this cannot be a simultaneous equation. There's a p and a q, where's the x and the y? And exactly, that's what I'm saying. It does not have to be an x or an y. You can easily get any letter that, let's call them unconventional letters. It's based on the scenario sometimes that's presented to you. So in this case here, of course, from here, once we recognize that we could solve it simultaneously, then we just do what we do as if it was a simultaneous equation. So here I want to eliminate, I could eliminate for P or I could eliminate for Q. Let me try eliminating for P. In this case, if I want to eliminate for P, I want the coefficients to be the same, and I could easily achieve that by multiplying this equation 2 by 3. If I multiply equation 2 by 3, I will end up getting the coefficient of what I need to be the same. So when I do that, I multiply everything by 3 to create equation 3. So this will be 12p. So 3 times 4p is 12p plus 3 times 6q that will be 18q, and 3 times 5, that will give me 15. And this will be my equation 3. And now I could eliminate 12p from 12p by subtracting. So I will do that. So 12p minus 12p, that will give me 0. Minus 3q minus 18q, that should give me minus 21q. And 2 minus 13, sorry, 2 minus 15, that should give me negative 13. Good. And let me just make sure that's correct. Yes, negative 13. And again, I ended up here with one of these answers that I don't like to deal with, but well, it is what it is. So I divide here by negative 21, and I'll do the same thing on the other side, negative 21. So that will leave me with Q being equal to positive 13 over 21. And 13 being a prime number, there's no way that could break down any further. I just want to make sure that I did the right thing here. 2 minus 15, yes, is indeed negative 13. So yeah, that is what it is. And negative 3 minus negative 18, the minus here will take precedence here, so yeah, it's 21. So yeah, that's it. Q is equal to 13 over 21. And now we substitute sub Q, saying Q and writing G. Substituting Q equal to 13 over 21 into another equation. Into equation, let's see, which one will I choose? Which one would work out nice? I'll find none of them working out so nice for that now. So let's try one. Let's try equation one. So equation one there was 12p minus 3q equal to 1. Hold on. No, not 1, 2. Oh, I see a mistake I made there. It's supposed to be 1 and not 2. But that's okay, people. It's 2 I had, so 2 I have to work with. Yeah, I thought that fraction was a little bizarre, but that's okay. I'll work with it too. Who said it have to be what I had initially? But I just thought it looks funny. Maybe if I had the one, it would have worked out nicer. Right, so here we have 12p minus 3, and remember our Q now is 13 over 21, and that's equal to 2. 13 over 21, this could work out, so 3 could go into 12 once, and 3 could go into 21 7 times. So that leaves us with 12p minus 13 over 7 equal to 2, right? I send that fraction on the other side. So I have 12p is equal to 2 plus 13 over 7. And this 2 could be the same as 2 over 1. I want the denominators to be common. So the 2 is the same thing as 14 over 7. I just multiply the top and the bottom by 7. That will give me 27 over 7 is equal to 12p. And here I just divide by 12, cancel this side, and I divide here by 12 also. And when I do that, to make a long story short, 27 divided by 7, all divided by 12, that will give me a total of 9 over 28. So P is equal to 9 over 28. And I just use a calculator to solve that there. So if I'm wrong, disclaimer on calculator. So this is P and this is Q. And again, not the best of answers to work with, because again, they're fractions, but it is what it is. The aim here, what I'm trying to bring out is the fact that, of course, sometimes we get unconventional letters, but even when they come like that, we do have to be able to solve them. Good. Let's go to the second example. And for the second example, I'm testing rearranging. So sometimes you get a simultaneous equation, and guess what? It might look like this. So this is number 2. The x's and the y's may not be lined up as you like or as you are accustomed. So you might have, let's say, 4y is equal to, and there we go with a big number again, 27 minus 3x, and they call this one equation 1. And then equation 2, they present you with something like 5x is equal to negative 2y plus 19. And that's equal to equation 2. And again, off the bat, of course, if you're looking at something like this, it's like, oh my goodness, how will I solve this? Because it does look tired. But once you get a scenario like this, again, all you need to do is rearrange your equation. Line it up how you're custom lining it up. As for me personally, I love to see my x's first. So I put x's under x's first. Then I put my y's under y's first. And then I leave my constant value all alone on one side of the equal sign. So yes, I have some work to do here. So the top, let's start with equation 1. And mind you, when you're rearranging your equation, you're not changing your equation. You just rearrange. So you still have the same equation. You just move around different values. So if I move this x over here, that will achieve what I want for the top. So it's negative here. When I go over, it will be positive. So here I will have, instead of negative 3x, I will have positive 3x plus 4y is equal to 27. And that is still equation 1. Notice only one thing I move and you see everything just fall in place, seemingly. Right. The 5x, I want it right there still. So I put my 5x there. But you see this 2 here? This 2y here? Let me change that color. This 2y here, I want it right below this 2y. So I will send this 2y over here. It is negative. So when you go over, it will be positive. So that will be plus 2y. And that will be equal to the 19. Oh, well, look at that. Only one movement I had to make. But I'm telling you, from the start, it did not look like that. Only one thing I did, I only transposed once, really and truly. And yeah, everything here worked out. Right. And the next thing here, of course, is to make sure that our coefficients are the same. That's the only thing we want to do next. So in this case here, I will want to make what? Oh, it's easy with the 4, with the y, I mean. So here, I will just multiply this equation by 2. Because when I do this 2y will become 4y. And once I have that, then I'm closer to home. Right. So that will create a new equation, of course. So that will now have 10x plus 4y is equal to 38. And that is my equation 3. And now I'm dealing with equation 1 and equation 3. So I'm eliminating 4y from 4y, so I subtract. And when I subtract there, I'm getting 3x minus 10x. That should give me minus 7x. Then I have 4y minus this number here. That should give me 0, because that's what I want. And then 27 minus 22, 38, that will give me what? 7 is 1, 2 is 1, so that's what, 11? What's happening? I'm getting a lot of wrong values today. I bet you I write the wrong number again, more than likely. So yes, I got 11 here. So then that means 7x is equal to 11. These are not the best values to work with. When you get values like this, then you think, let me see. I have 4y. 4y is equal to 27 minus 3x. And then I have 5x is equal to negative 2y plus 19. I don't know. Those are the values that I have. So I divide here. X is equal to negative 11 over 7. That's what I did when I get rid of the negative 7. That's what it is. That's what it is. That's what it is. Right. And then I want to plug that into another equation. Which equation might be the best for me to put that? Well, it doesn't really matter. No. Let me look at the one with the smallest value, and that would be who? There are none here. So I will take equation, let me take equation 2. I'll take the original equation 2. So that would be, let's see, equation 2, 5x plus 2y equal 19. So we have 5x plus 2y equal to 19, and we are substituting x is equal to negative 11 over 7 into equation 2, right? And then we have equation 2. Wherever we see x, we just put in that. So instead of 5x, it will be 5 into, that's negative 11 over 7. Yes, plus 2y is equal to 19. And we're looking for x, of course, not xy. So we could distribute this one here. That will leave us with 55, negative 55 over 7 plus 2y equal to 19. I transpose that, so that will be 2y is equal to 19, we'll put it over 1, plus 55 over 7. My, these answers are bizarre, like trust me, bizarre. You would not, I trust you would not see this type of answer for CSEC. Well, unless you're working at higher level maths. But for CSEC, you should not. As I said in your video on Monday, you usually get questions that solve honestly pretty neatly, yeah. Sometimes you get a whole number, sometimes you get a number that you could relate to. You wouldn't get these fractions and then trust me. So this year I end up with 188. When you solve that, you could just use your calculator here, over 7. And then of course I'm dividing both sides by 2. So y is equal to, when divided by 2, this is the same as 94 over 7. Man, and I'll leave it like that. You could write that as an improper fraction. That will be something like what? That will be a big number. It's like 711. 711 is a 77. 712, that's 84. 77, 84. So that will be 713. There will be 13 and 3 over 1 or something like that. That's some big number. 7 14s are 21, 91. So yeah, even this one that we got for x could even be written as a improper fraction, mixed fraction. Whatever. I trust you wouldn't get questions like those. Trust me. For CXA, believe me, you have nothing to worry about when it comes to that. And then we're going to do the last one, question 3. Question 3. And that is if you meet up with a word problem. So here you have a scenario. They said a rectangle has a length. I usually have problems spelling the word length. Sometimes I mix up the H for the T and the T for the H. Of 4 centimeters more, oh, interesting, 4 centimeters more than its width. More than its width. Even width I struggle to spell sometimes. Right? So then they said, if the perimeter, and I trust we know what is perimeter. The perimeter of any given shape is the distance around. When it comes to a circle, sometimes the perimeter is called the circumference, but it's the same concept. I hope this one worked out nice. That's the price I pay for just making up random questions. Yep, random questions. As I said, if you think over these questions, oh, and length. Okay, so this one is a word problem. And again, as I said earlier, it's a disguised simultaneous equation, and sometimes we don't see it like this. One of the things I love doing, and I always advise my students to do the same, whenever you get a question, you draw. Whenever I see something that you could put in words or you get in words, draw. So they say a rectangle has a length of 4 centimeters more than its width. So in other words, the width is 4 centimeters less. So any way you want to look at it. So I would draw a rectangle, first of all, and we don't know the length, we don't know the width. But we know that the length is 4 times more, or the width is less, whatever I want to look at it. So let's call this length here, let's give it a letter. What about M? So let's call it M, and let's call this here, this is the length, this is the width. We are told that the width is 4 centimeters, no, the length is 4 centimeters more than its width. So that means the width will be M minus 4 equal N. Or you could do the other way around. You could have easily said M plus 4. Now, M plus 4 cannot equal N because the width is less. So the length would be M and the width will be 4 less than the length. So that's how we get N. Yes. Oh, and watch, I might make this look a little simple, but this is not as straightforward as it seems. Good. And on the other hand, we could also say that the width is N, right? The width is N, but we don't know what is N. We know N is 4 length less than M. So that's that. So we get two things here. Oh, and we know the perimeter. We know the perimeter is 28. So let's figure two things out. We know that one of the sides will be M minus 4 equal to N. And we establish N to be the width. And we also know that the perimeter is 28. And remember, the perimeter is the distance around. So that would be, technically we're saying M plus N plus N. The two lengths and the two widths, when you combine them, you're supposed to get 28. So this is the same as 2M plus 2N is equal to 28. That's one way to look at it. And once we could figure this out, the rest is a walk in the park, really, because now this is a simultaneous equation, but really and truly is not the conventional one. Because I will take an easier route to this. If I know that M minus 4 is equal to N, then this means that M is equal to N plus 4. And that makes perfect sense. But you don't even have to go there. We could leave it just so. We could work with N. We know that N is M plus 4. So wherever we see N, we put this value here, this entire value here. And then we solve for M. And that is a typical way of solving a simultaneous equation. So here we have 2M plus 2 multiplied by M minus 4 equal to 28. And we just solve. So here we will have 2M plus 2M minus 8 equal 24. 2M plus 2M, that is 4M, minus 8 equal 24. I send this on the other side. So 4M is equal to 32. And when we divide by 4, M is equal to 8. Nice. So that means the length is 8 cm, and here it will be 8 minus 4, so the width will be 4 cm. And that's the length and the width. 8 plus 8 is 16, plus 4, 24, plus 4, we do indeed get a perimeter of 28. So that's another way in which you could get at this guy's simultaneous equation. Although here, to be honest, I solve it more algebraically just to save time. But you could easily solve it simultaneously again by just making the coefficient of N or M the same. And then you solve for either one of them. And you should end up with the same one. This ended up being a pretty lengthy video. So again, sorry for the length in case you're just looking for a crash course. Maybe I could always try and do a crash course later. But that should bring us to the ending of today. So again, as always, feel free to like, share, and subscribe. And until the next time, you take care.